Yeah, g'day, and welcome back to my channel. I've been working on a replica of a 1920s motorcycle engine. It's pretty rare. It's called the Redrup Radial. It's a cute little 3-cylinder radial engine. So far I've got pistons done, and last week I prototyped my cylinder head castings. Luckily this week I've got a public holiday on Thursday, so I've taken Friday off work to give me a long weekend, and I'm going to do my best to cast a full set of cylinder heads, make up the fixtures to hold them in the mill, and machine them, get them all finished. So let's see how that worked out. Now to do my production castings, I've got two options. I did my prototypes with green sand, which is sand with clay bound together with water. And that did a pretty decent job, but it does leave a reasonably coarse surface finish. The second option is I've got some oil-bound sand. In America, this is normally known as Petrobond, is one of the main brands. Now that's made with a much, much finer sand, bound with clay, and I believe it's similar to two-stroke oil. So it has the advantage of normally giving a much nicer surface finish, but I'm not sure if that's what I want to use because it may pick up some of the striations and layer patterns from my 3D printer, which wouldn't look very genuine on a 1920s replica. But today I'm going to give it a go because I'm curious. Now, because everything about the sand's different, first thing I'm going to have to do is clean all of my green sand out of my muller, as I don't want to contaminate my nice oil-bound sand with the coarser green sand. So while the normal sand feels somewhat, let's say, normal, this stuff feels much more like Play-Doh or crayons. It's got a very sort of a waxy kind of a feel to it. It sure takes a lot more effort to ram up this oil-bound sand than it does normal green sand. See all these indentations here? That's from not ramming the drag hard enough. So when I rammed the cope, it forced itself partly down into the drag. And now it's raining. Hope that goes away, otherwise there'll be no molten aluminium today. Out of curiosity, I rammed up 2 patterns in one flask just to see if I could get 2 good castings at once, but one of them didn't fill properly, so I went back to just doing a single pattern in each flask. One of the worst aspects of the use of oil-bound sand is the amount it smokes, and it keeps smoking for quite a long time as the metal solidifies and cools. You get another big burst of smoke once you open the mold and shake it out. So after this one I started using a charcoal filter in a mask to not breathe it all in. I just got that one casting done, and then unfortunately, just after I shook them out, it hosed down. And there's another thunderstorm just going to pull past in the next 20-30 minutes, so I'll just pack up for now. Right, well, I guess I'll have to leave it with just 2 castings done today. That's a bit unfortunate. I was hoping to do a second session, but rain stopped play. Oh well. Here you can really see the quality difference between a general purpose, somewhat coarse green sand, and then that oil-bound sand or Petrobond. Looks fantastic. Right, next day. Today we've got a forecast for no rain. That's good. Let's try and get these cylinder heads finished. In addition to my cylinder head pattern, I'm also going to ram up this pattern which I made for one of my friends. It's the cover for an angle gearbox drive for a Magneto or a 1920s racing motorcycle. I think it's a Nuh More. So I made him a couple of these a while ago, and my mate Franz asked me to make up another one for him, so I'll do that now. Oh bugger. I was breaking the feeders and risers off using pliers and broke one of my fixturing tabs off. That sucks. Now I just need to fettle the castings so that they'll actually sit flat on their fixturing blocks. These don't need to be pretty because they're just going to get machined off afterwards. Just need to make sure there's no high spots. Right, let's do a quick inspection. I've got a bit of a joint defect or something here. That's going to be easy enough for Franz to just dress that off with a file. Otherwise, this is, I think, the better of the two of them. Pretty happy with that. The other one's got a bit of a defect on top. A few little spots of loose sand. Something happened there. Maybe he can use this one to practice his machining on. Right, what about these? First off, looks like everything around that spark plug boss has formed really nicely. Maybe a very minor defect on the front of that one fin. That's pretty irrelevant. I hear there's a bit of flashing or something going on there. I think this one's definitely going on the good pile. I think some of them I didn't ram the Petrobond down between the fins quite hard enough, so you get a slightly rougher finish in there. Also the side of the fins have got a wee bit of some sort of a mark or defect on them. Nothing I can't live with. Oh, there's a bit of a wart that'll need dressing off. I'll put that in my seconds pile. Something a little bit funky happened under here as well. Not exactly sure what caused that. Probably a bit of movement when I started ramming or something. Also across here. I think this is the first one I did, one of the early sand castings. It's going to need some dress up under the spark plug boss. Here, this one's also got a kind of a weird movement or something on the top. Probably the very first one or two hits with the rammer moved the pattern. That's what I'm guessing caused that. It's a shame because otherwise that's a pretty good casting. This is another green sand casting. Also had something move here, so I've got a fin extension that I can remove. And a wart down below it. The boss came out quite nicely. There's a very slight defect in the radius there. Also a wee bit down underneath. But I think I can put this one on the good pile. So I've ended up with 4 on the good pile. And 5 with defects. Right after casting, the aluminium is kind of soft and sticky and doesn't cut very well. It tends to build up on the tools, so it needs heat treatment. So this goes in on fan bake for 6 hours at about 205, 210, something like that. Right, they're now done. Right, those are now cooled down. So let's go and get them machined. Mail time. This is from Andy in England. Aha! Looks like an assortment of Whitworth and British Standard fine screws, as I have some missing ones on my Jones & Shipman grinder. Thanks, Andy. To machine these, I'm going to need 4 different setups. The first one is just taking this down to a specific height above the combustion chamber. The second operation is going to be putting in the screw holes. The third operation, drilling, boring, threading the spark plug hole and putting a bench on there. Probably also relieving on the back a little bit so I don't have threads eroding on the edge of the combustion chamber. And then the fourth operation will be simply taking off my fixturing features here on the end. My first fixture is going to be based on these 1, 2, 3 blocks. Actually 25, 50, 75 blocks because they're metric. That gives me some clearance above the table for this bit. Then to clamp it, I think what I'll need to do is just pad that up with some aluminium scrap. Probably put a second piece of aluminium over the top as a clamp. And that gives the advantage that the same fixture can be used for my second operation just by flipping it to then drill all the holes. Right, now for operation 3, I've got this cheap import angle plate. I don't know how accurate it is, but all I'm doing is putting in a spark plug hole. So I'm going to need to mount this somewhere here at 45 degrees. And I think the best way of doing that is first put a tooling plate down, bolted to the table, put in at least 2 dowels that are quite close tolerance to align this, because by this stage it'll have the holes in it. And then use other holes to screw it down. And then I can get in the end here and do all the operations on it. Now for the last operation, which is going to be taking off these fixturing bits, I can use that same fixture plate in the vise, and then it's just a matter of a curved toolpath to take them off. So as is typical in machining, before I can actually start working on the part, I need to do some fixture making. Right, I found a couple of bits of scrap aluminium. So, chop this one in half. I'm really glad I did that gearbox repair on the Dual. It's cutting really nice nowadays. When you first turn on the Maho, the first thing you have to do is home the machine. a bit of wax to stop any coolant that gets underneath from causing corrosion. With the chuck installed, the next thing I'll do is use the Haimer 3D probe to touch off on the rear left-hand edge of the chuck jaw. I find the hydraulic drawbar super convenient on this machine. With the Haimer 3D probe, all I have to do is run the probe up until it's indicating 0 and then set that to 0 in Linux CNC. And you do that for each axis. I think I'll use my insert cutter, but it's currently set up with steel cutting inserts. These are the high positive rake polished inserts used for cutting aluminium. Now I can also adjust the tool offset. I do this off a carbide bar of a known diameter. Now the first part of this process is just simply squaring up the stock. There should be nothing interesting or very dramatic about that. But halfway through this, I didn't notice at the time what had happened, but something moved. Did that vise slip? Oh, wait a minute. It wasn't the vise that moved. Whoa, that was nowhere near as tight as it should have been. 5 bolts, only one slightly done up. Right, now I'm going to have to tram that head again. Yep, that's a 20. Gearbox in neutral. I don't know of any good way of doing the fine adjustment other than just bumping it backwards and forwards. It's pretty easy to bump it past where you want it to go, so it's just a bit of playing around really. Okay, it always takes a bit of dicking around to get this adjusted, and of course I always double check, so if I take this one right out of the game, so here we're zeroed, just lift that up, flip it around. I can sort of get it within about 1/100th of a millimeter. That's like 5 microns on that distance. So I'll leave that at that for now. Now I can get up underneath because the 5th bolt is up under there. The last stop on these clamps was to drill some holes, but I got an error. Arc clearance plane unspecified in the cycle. What the fuck? Okay, so why did that happen? Each of my tools is a different length. So you have to have a tool table telling Linux CNC where the tip of each tool is. For example, our drill is tool number 5 and it has an offset length of 65 millimeters. At the moment, that offset's not set. To set an offset, we use G43. Okay, and now, where's our tool? Our tool is 10.5 millimeters above the 0 reference, our plate, which is correct. So you can see which offset it's using, and that G43 use length offset is currently active. The mistake I made, I told the machine to do a drill cycle, G81, from wherever you're at, which is 10 above, go down to -13, so 13 millimeters below the top of the material, at a feed rate of 100 millimeters per minute. But when I told it to do that, it errored out. And the reason it errored out, this command needs an R for a retract plane, because once it's done its PEC cycle, it needs to know where do I have to come back up to before I can move off and do the next thing. I caused an error by not giving it a retract plane. One of the behaviors of Linux CNC is anytime it errors out, it cancels tool length offset. G43's gone, the offset's no longer in use. That's tripped me up before. I think it's a terrible behavior. There was some discussion on this in the forum. Anytime the tool's set, I want that offset, but it's not basic behavior to this program. That still doesn't answer why did it punch through at high speed. With my tool offset now cancelled, the machine thinks the tip of the tool's right up at Z70. I gave it a command of do a drill cycle starting at a height of 10 and go down to -13. Now, because it thinks it's so high, the first thing it does is wrap it down from 76 buff to 10. Luckily, the spindle was turning. It was only aluminium, so it punched through the aluminium without a problem, and it came to rest. There you can see the little divot I put in the nut of my vise. I believe the only thing you can do to prevent that sort of thing is to set I think it's the longest tool you own as like your default tool number 0, so that every other tool has a offset in the safe direction. I'm not sure though. I'd have to have a look at that. Okay, with that first fixture finished, let's just clamp down the back bit. I guess what I'll do is just run an indicator along there and wiggle this around until I get it square. I'll do that a few times because castings always have some variation to them. This is the fixed jaw in that direction, and there's a bit of wiggle room. And then to clamp them down, the top pieces, one goes here, and here. Put a clock on there. So I tried it out with 3 different castings and kind of averaged out the errors between them. Ended up with it straight within about 1/10 of a millimeter or so. That should be fine. Next up, I need to find that center line. I've just zeroed out my height to this point, because with the draft angle, I need to return to exactly the same height to get to the same spot on the other side. There's our center. Right, now to find the middle point in Y, I'll flip it over. Because now I can touch off on these 2 points. I've handwritten a little program for this. This is just my test cylinder head, so let's try out this program. Battery went flat on my camera during this pass. Right, well this was just the test piece. This didn't get heat treated, so it'd have the worst, gummiest aluminium. I only took a 0.5 millimeter per pass. I'll try slowly upping that, but it's all pretty flexible, so I kind of doubt I'll be able to get a very heavy cut out of it. Alright, first production part. Right, now I still have one more to do, and that's the one where I broke the fixturing tab off. So I've just made up a little stack of shims there to bring that up to the correct height. Spacer goes in there, and then another couple of shims on the top piece to grip it. Seems good. I will drop the depth of cut on this one. I think I'll just do 0.5 millimeter passes. Well, that worked better than I hoped it would. So that now ends operation 1. Operation 2 is going to be counter bore on each of the hole locations and then drilling the holes. But the issue I'm seeing is there's enough variability in the length between that face and this face that just plopping this in means I'm going to end up with quite a lot of variation in the position of the bolt holes along here. So what I think I'm going to have to do is first put them in upside down, probe that position, set a center point off there each time, and then I can flip and do the rest of the machining. It's going to be a bit of a faff around, but that's what happens when you're working with castings. Things end up with a bit of variation. One of the cool things about CNC machines is that they all have these standard can cycles. Like this G81 means drill a hole at this location, down to this level, at this feed rate, and when you're done, go back to this retract plane, 25 millimeters above the work. The coolest thing about it is that's a modal code, so once you've set all of those parameters, after that, just giving it different coordinates means it'll do exactly the same thing every time it gets to one of these. So this is a really fast way of programming bolt hole pattern or something. Right, let's give this a quick go and see what it works like. I'm just realizing that I changed my model of this after doing that. So the question is, do I want to leave these scars in the sides here? I guess the first thing I'll do is drill all the holes out and then decide. Nope, that's not going to work. I already need to adjust the length of my drill because I just kissed the top of the part there, but the spot drill's never going to get down there, so I guess I'll just drop that excess. I'll just drop that off. Okay, will this work? The whole pattern doesn't look too bad. Although I touched off first, I'm obviously still not centering those. I think this hole needs to come in 0.5 millimeter, but otherwise the pattern looks basically fine. I've adjusted the length of the drill so I don't kiss that anymore. I took another look in my drawings, and as far as I can tell, it looks like Charles Redrup used slotted screws and not hex head screws. So I'm going to drop the size of that spot face down a little and also make it less deep, just to reduce the amount of scarring I put on this boss. I think I was too generous with the size of my boss. I'm pretty sure that the original was probably a bit smaller. Okay, I've now got one set of 3 up to this point, but unfortunately, I'm starting to get that sinking feeling. Just realized that I made this boss way too big. The spark plug's 22 millimeters through here. I've beefed that out to 27 millimeters, which is kind of excessive. And because of that, I got no clearance on my holes. And I also think this needed to be moved down this way, a couple of millimeters. At this point, I'm really starting to wonder whether it makes any sense to continue on machining here just in case I pick up some other issues that I'm going to need to address with a new pattern. But really, I think all of these heads are going to go back in the pot. Bugger. I always get super keen that I'm going to get a whole job done in 1 week, and then I sort of push it too far, and instead of slowing down a bit, end up doing lots of effort in the wrong direction. The good thing is all of this setup is now dialed in, so once I make new heads, it's going to be much easier to zip through them and start machining them. Let me just make the second fixture plate, the one I'm going to need anyway. Too slow a feed rate there. That's enough, I don't need all of the holes tapped. Okay, well, I guess I was a little bit optimistic. It's a bit unfortunate that I made that error on the spark plug boss. I think the reason I made it was I programmed in the drill holes into an earlier version of the cylinder head, and then when it came time to actually use those holes, I didn't recheck them on the most recent pattern, which had this particular boss size and shape on it. So that's on me. Yes, so next task is going to be to modify that pattern, reduce the size of the boss, move it a little bit. I still need to have a bit of a look at the spacing of holes and ribs and stuff to make it all fit. But I'm really glad I got my fixture plates made, both this one, which I haven't used yet, and the ones which I have. So at least next time, when I have hopefully corrected castings, the machining part should go a little bit faster, I'm hoping. Thanks a lot for watching, and I'll see you next time.